Morning, everybody. Hope you all enjoyed your break. I had a great break. Really need that day off or 2 days off. I feel energized, recharged, ready to get through the end of the semester. A couple things I want to remind you of, or actually two things. First one is your access assignment. I think it's called access wrong, but your access assignment is due tonight at midnight. 11:59 is the way Blackboard works. I know you guys have some individual questions, and that's great. You know, that's what working with computer applications is all about. You know, kind of working your way through things, and that's how you learn. So this is a good assignment. I know you had some individual questions I didn't get to at the beginning of the class, and I apologize. So I'll tell you what we'll do. Someone tell me when we hit 8 or 9:30-ish. Okay, 9:30. Okay, don't let me go on and on past 9:30. Because what we'll do is we'll reserve the last like 15 minutes of class, and if you have questions on your assignment, I'll come back and help you. Okay, so that's what we'll do, 15, 20 minutes of class. But we do have some new material. The other thing I want to let you know is I put out, this is chapter 5 material, okay? And we're done with chapter 5. We kind of skipped a lot of things in chapter 5, but we got I think what's important from chapter 5. So I put out a quiz that's due next Wednesday, I believe. It's on Blackboard, okay? And it is 20 questions. You can do it twice, and it's timed at 45 minutes, the same kind of deal. And I kind of limited the questions to just the stuff we talked about, like primary key, foreign key, those kind of things.
What day did you say it was due? 29th.
Is it the 29th?
Yes.
I think it's next Wednesday. Yeah, is that what it is on the Blackboard? I thought so. I set it up yesterday. Okay, so what we're going to talk about today with the next, 25 minutes or so, is we're going to go to chapter 6. And chapter 6 used to be called Networking and Data Communication. They renamed it to the cloud, okay? Because now what they're saying, and remember I told you cloud was like the big buzzword a few years ago. Now it's like big data, and there's sure will be another buzzword next year. But cloud is what they renamed this chapter to, but it's still behind everything is networking basics, okay? So I'm going to start kind of a reverse in this chapter because I still think it's important to understand networking basics before we start talking about the cloud. So we're going to skip over some of this. You know, the cloud, as you guys know, I've drawn it in class, is basically meant to imitate like, hey, it's somewhere on this internet, this network, right? We don't know where it's at, but it's in this nebulous thing called the cloud, right? Nice jacket. Okay. So what we're going to talk about, though, is before we get into the cloud, I want to talk about networking a little bit and start talking a little bit about networking and networking hardware. So some of this is not new to you. Some of this you probably saw in high school, in Computer Science 101, but it's important stuff, okay? The first thing is we're going to talk about the types of networks we have. The first one is a local area network. Now, a local area network is computers connected at a single site. So this is an example of what's called and this is a good acronym, small office, home office, SOHO, LAN, okay, local area network. And we network things together. Why? Why do we network things together? Let's start with that. Why do we network things together? Why do we network things together? Pablo?
Share documents.
Okay, we share. Share is the key word there. Share documents, share resources, whatever it may be. Instead of me buying everyone a printer or buying everyone a storage device, if we network it together, we can share these things, right? We can share these things. And in fact, you know, that's what the internet's all about, is sharing things, being able to collaborate, being able to work together. There's a famous law. It's called Metcalfe's Law. Bob Metcalfe was one of the founders of the internet, if you will. It's called Metcalfe's Law. It says the usefulness of a network is n squared. From stats, what is n? What is n?
52.
The number, right? The number in the sample size. So the usefulness of the network is n squared. The more people on the network, the more useful it is, right? Think about eBay as an auction network. If it was just me and Jerry, not very useful. Like me and Jerry exchanging things, he has to want it, I want to sell it. But now we put a lot of people on it, man, the usefulness of it takes off. So a network is useful because of the number of people on it. So a LAN, a local area network, is the first thing. That's computers connected at a single site, okay? The expansion of that is something called a wide area network. And a wide area network is computers connected over some distance, right? We might be on the same network, but we are connected over some distance. For example, we may have multiple branches of a bank, and they're connected on the network together. That's called a wide area network, because we might have a branch in Altoona, a branch in State College, and a branch in Johnstown. So the wide area network is a little bit different. We'll talk about the physical differences as well. And then sometimes we have what's called a MAN. Okay? And a MAN stands for Metropolitan Area Network. Okay, Metropolitan Area Network, where it's like a city. Okay, we're talking about we're connecting things in a city, or sometimes a CAN, which is called a Campus Area Network. St. Francis, we have a CAN, right? Because you can be in SCOTUS, you can be in Christian, and you somehow are connected together. Okay, so that is the deal. Now, we also hear the term internet. Okay, and I'm going to draw this first, or I'm going to write this first with a lowercase I. An internet itself is a network of networks. It's an inter-network, right? And a network of networks is an internet. So if I had a network at my house and the neighbor had a network and we connected those together, hey, we have an internet. All right? We connected someone else's network together, we have an internet. Okay? But that's different than the internet. Okay? The internet is a capital I. Why is it a capital I? Because it is the internet, right? It is the internet. It is like the president of the United States, not like president of the entrepreneurship club. It is the president of the United States, right? That's the president. Yes, you guys know what I'm saying? So the internet, okay, the internet. Now that is a network of net, and sometimes it's called the public internet. Why is it called the public internet? Why is it called the public internet?
Anybody can use it.
Okay. What happened, and I think I told you maybe the development of the internet, I think I mentioned this earlier, is the government developed it as something called the DARPANET, okay, or sometimes called the ARPANET, the Defense Advanced Research Project Agency Network. And they connected together these universities, and they had it going for research and all these things. And they said in 1992, by an act of Congress, okay, Congress didn't come up with the internet, by an act of Congress, they said, hey, we've developed this thing called the internet, right? We're going to make it public. We're going to let anyone use it, right? And what happened when you let everyone use it? What happens when you let everyone use it? So they had some stuff going on, right? They shared files, they shared resources, they shared research data, these universities, the government. But what happened when they made it public? Yes? You raise your hand? Just flinch. That's all I need, is flinch. What happened when they made it public? 1992, I was just graduating college. You guys were born?
Nope.
You guys were not even born. How am I old? Okay. What happened in 1992? You guys know who Al Gore is? You ever hear Al Gore? You ever hear like that he claimed like he developed the internet? Did you ever hear that's sometimes attributed to him? He didn't really claim that. He said he was integral in the legislation that made the internet public. And he was, okay? He was. But by an act of Congress, they made the internet public. And what happens when you give everyone, basically, and I've used this before, keys to the factory? What happened once we made it public? That's the great thing about business, and that's the great thing about entrepreneurship. What happened? What kind of things happened when we made it public? Give me one thing that happened between 1992 and now on the internet. Anything. Yes?
Businesses like Amazon and stuff.
Businesses like Amazon, right? Amazon, Jeff Bezos said, you know what? What did Amazon start as? It's a good example. What did Amazon start selling? They started by books, okay? The first name of Amazon was Cadabra. Like abracadabra, that was their first name. But they nixed that. Why? After a while they nixed it because it sounded like Cadabra, right? It sounded like something dead. It had a bad negative connotation. So they went to Amazon, the longest river. They wanted to be the longest. So they started with books. And they purposely said, we're going to lose money for a while. And they lost money for a long time because they were building what we call mental market space, right? They were trying to associate like brand equity with what they were building. What else came out of, and that was even a little bit later than 1992, but Amazon is one. That's, retailers. What else? What else? eBay, okay. eBay, there was auction, and that was a huge thing, right? That was a huge thing. what happened in 1992, you guys remember the dot-com bust? You guys know what I'm saying the dot-com bust is? What is the dot-com bust? Pablo, what's that? Go ahead.
All the stocks crashed.
But why?
It was a big bubble. Everyone started investing.
Okay, bubble. Everyone thought, hey, this thing is going to transform the world, and it has, right? It has. So no doubt the internet has transformed the world. But what happened is people said, hey, this is going to transform the world. So they just started investing in things that really had no business model or no, people weren't willing to make the jump to that yet. So everyone started investing in these dot-com stocks. If you throw out Miko.com, people wouldn't invest in it. Like, oh, I don't know what he's doing, but Miko's doing something. And there was really no money coming in, no business case. So eventually what happened is it crashed and it was a bubble, okay? But what has happened now is all this infrastructure, all these things that are built is because they made this resource public and entrepreneurships took advantage of it, right? Entrepreneurships took advantage. Social media, Google, all these things because they made this public. But it all starts with networking basics, okay? Let's start talking, we're going to talk about the small office, home office basics. So, a couple things. Let's start at the very lowest level. First off, for things to be on a network, they have to be unique. We have to identify them uniquely, right? If me and you are on a network, we need to be unique. I need to be me, you need to be you, and the network needs to know me and you, right? They need to know the difference between us. How do we do that in a network? What's the way that things are uniquely identified in a network, including the internet? And I'm going to simplify this because there's more to it, but go ahead, Ian.
Yeah, IP address.
Okay, have you ever heard the term IP address? Yes? Have you ever heard the term voice over IP? What is IP then? What's an IP address? What's voice over IP? What does IP stand for? That's a good place to start. IP stands for Internet Protocol. Protocol is the way things are discussed, okay? IP stands for Internet Protocol. That's the language of the network, right? That's how the communications happen on the network. So right now, if you go to your computer, I'm going to go to mine, and go to your start file here, your Office button if you have this, and if you have 2000, if you have a Windows 8, swipe on it, and then I think you just put in the box CMD. So I want you to get to a CMD prompt. Okay, this window. I want you to get to a command prompt. And if you have a swiper, 2008, type in CMD, and yeah, go to command prompt. Okay, so I want you to get to this. So it should say command prompt, and click on that little app, okay? I want you to type IP config. Go to command prompt. So if you have Windows 8, you have to swipe, and in your search bar type CMD. You find it, Katie? And then type IP config. And I'm not a network expert, but I do know a little bit about networking. And if we type IP config, it returns some things, okay? Our IP configuration. And a couple things I want you to look at. There is, I think we're using IP version 6 now, which is kind of ugly. But let's look at the IPv4 address. So my computer up here, you see is 10.0.2.114. Pablo, what's yours? Did you do this? No?
No.
Okay. Who did this? Katie, what's yours?
10.50.14.68.
Katie, what's yours?
10.50.0.1.
Okay. Notice everyone has a different one. That is actually an internal IP address. The connection you have to the network right now, you have a unique address assigned to you. That's called your IP address. That is what makes you unique, okay? Now the same is true on the internet. For example, if I go to, I'm going to fill out my command prompt, if I type ping, okay, and ping means like send like a signal and wait for it to hear back. You guys ever watch like The Hunt for Red October? Great movie. No? Get it if you can. It's a little bit Sean Connery. But anyways, a ping is like send out a signal and it sends something back. So ping and I'm going to put in here ping space portage. This is a website, portagepa.com. Okay, and it returns back, all right, I sent some data to portagepa.com, and it says, hey, portagepa.com, did you know, also goes by 209, can someone read that number to me? 209 dot,
197.
go ahead, Plummet. 85 142, okay. So, guess what? If I go to my web browser, and instead of typing in www.portagepa.com, if I type in 209.197.85.142, and I hit enter, what do I do? Oh, okay, thank you. If I put in 85, okay, it goes to portagepa.com, okay? Now, that is the unique address of portagepa.com, 209.197.85.142. That's unique on the internet, right? That is its address. Yes, that's its address. All sites like that, so when it reads that, it says, hey, 209 is this server, it's actually a server in Pittsburgh, and look in this folder, and retrieve that HTML and display it. That's what it's doing. Now, we don't work like that. We don't work like robots. We don't say, hey, go to 209.197.85.142. So we need to put a human convention around it, and that's something called the domain name system. That's portagepa.com or Dell.com or Amazon.com. But really, IP address is the thing behind it that keeps everything unique. Okay? Now the IP address that you saw your machine, that's not a global IP address, that's a local IP address. So you just have to be local, unique within our local, our CAN, our campus area network. Okay, so let's just hang on to that for a little bit. So if I go back to the slides, let's talk about that. So first, we need a unique IP address. That's the first thing. Okay, we need a unique IP address. We have that. Now, let's talk how we connect. So if you are back in your dorm, does anyone plug in? Does anyone plug in to connect to the network? Okay, you plug in. All right. So what happens when you plug in? You are plugging in, what kind of cable? What do you call that cable you plug in? Go ahead.
Ethernet.
You call it Ethernet, okay? Ethernet is actually a kind of protocol. And Ethernet is up here, you see it says, uses IEEE 802.3. 802.3 is, think of it just as a language or a protocol, is known as Ethernet. So you plug in your Ethernet cable, and with that Ethernet cable, you have a port in your room. Your port is connected through the ceilings. If you ever saw Kevin, the guy that works here, sometimes climbing in the ceiling, you guys know what I'm talking about? No? Well, anyways, Kevin climbs through the ceilings and he routes this stuff. And when you plug in your port, you're making a physical connection between your computer and something called the switch. Okay? The switch is kind of the thing that brings everything together. So you plugged into this port, and maybe your roommate plugged into this port, and then guy 7 rooms down the hall plugged into that port when he plugged in. So it all comes together in this switch. The switch has a bunch of ports, like Cisco makes these switches. You guys hear of a Cisco company? Okay. So we are physically connecting to what's called the switch, okay, through 802.3. What's the other way that you connect to the network? Like right now, you guys are connecting to the network, but you're not plugged in anywhere. I don't think anyone's, maybe you're plugged in for electricity, but you're not plugged in for networking ability. So how are you getting access? Okay, so something called Wi-Fi. Wi-Fi, okay, is known as 802.11. And there's different, that's called Wi-Fi, and there's different flavors of it. A, B, G, N, and all they have to do is like the speed of it. So just know 802.11 means Wi-Fi, right? So right now, you're connecting to what? What are you connecting to? You're not connecting directly to the switch because you're speaking in Wi-Fi. You're speaking in 802.11. So what are you connecting to? It's not a router yet, okay? A lot of times they're together. But what do we call that thing in the ceiling there? Okay, and an access point, what it does, okay, all an access point does, that access point in the ceiling here, you guys can see, you guys are connecting to it, it's beeping and all that stuff. It is actually hard-coded with an Ethernet cable back to a switch. So this is plugged into a switch, right? This is hard-coded, hardwired to a switch. You're connecting to this, and it's hard-coded. So you guys are connected to this access point, and this access point is taking up one of the ports on the switch, okay? Now the way you're communicating to that access point is through what language? Wi-Fi, which we call 802.11. But we know, hey, this switch needs to communicate, all this network traffic is in 802.3, so it's actually converting 802.11 Wi-Fi to 802.3. It's kind of like a translator, right? And now you're plugging in through this access point, which is plugged into a switch through this port. Okay, does that make sense? Now, if I plug in, what's kind of nice is I take a whole port myself, right? I'm plugging into a port. If I'm using this access point is one port on the switch, and you guys are all sharing that, right? So it's like when you never notice how wireless is slower than plugging in? You guys ever plug in when you're off in your dorm? It's going to be faster because you're getting your own dedicated port on the switch instead of sharing an access point port to the switch. Does that make sense? There's more complicated to this than that, but I'm trying to make it simple. Okay. All right. So 802.11, 802.3. Now a couple of things. Inside your computer is something called NICs. Okay. NICs stand for, God bless you. NICs stand for Network Interface Cards. Okay? And network interface cards are cards in your device that help you communicate to the network, right? You have to have a NIC inside your device to interface with the network. Okay? It has the logic in there on these cards. In your computer, you actually have two NICs. Okay? You have an Ethernet NIC. So when you plug in, you interface through that network interface card, and you'll have a wireless NIC, so that you can communicate with the access point. So you actually have two internet cards in your machine. Okay. Now those devices themselves, these network interface cards, let's see. Okay, so if I go in here and I type ipconfig/all, I'm not real good at reading these. Oh, okay, yeah, it's right here. Okay. There's actually an address associated with a network interface card that never changes. Next time you log into our network, you may get a new IP address. So it might change. It might say, hey, this time you're 10.0.7.92. It's called dynamic addressing. But the one thing that doesn't change is your MAC address. Okay, it's a physical address on your network interface card. And you see it here. The physical address on this network interface card is 78-45-C4-0D. Those are hex numbers. You don't have to worry about that. But that is the address of that card. It never changes. So if I use that card, it's always going to be, it's burnt into the firmware of that card. Okay? So that always is associated with your computer. So you might say, well, how can they tell it's me? Well, they can tell it's you because they know your network, they know it's this machine because that's their network interface card. Even if you log in as someone else, it all goes down to that level. Okay? So we go back to our little drawing here. And we know we have network interface cards. We know we have 802.3, which is Ethernet. We have 802.11, which is Wi-Fi. We have access points. We can network all kind of things like printers. There are also just nodes on the thing. We can network like any kind of shared device like printers or 3D printers or whatever it might be. We can interface those kind of things. Now, that is a home office LAN or a network. We have to go out, if we want to touch other networks or an internet of networks, we have to go out of our network, okay? How are those connections made? Like connections from like maybe here to Pittsburgh. What are the ways we connect from here to Pittsburgh? It's not an Ethernet cable. The Ethernet cable is too slow. What is the cable you see them sometimes burying by the side of the highway? Go ahead, what were you going to say? Oh, say.
No, I guess I-
You ever hear of fiber optic cables? You ever hear of fiber? What's fiber optic cables? Maybe you got them at the fair. Remember those things you turn on the light and the light comes out the end? They're like plastic things. You guys know what I'm talking about? Those are fiber optic cables. Basically, they're a cable that has a mirror inside the cable, like mirror cladding, and then light signals go through it. How fast does light move? The speed of light, right? I think it's 186,000 miles per second squared, right? So it moves very damn fast. So those signals, those light signals, are storing the ones and zeros. So that's why we can text someone, or not text, but we can instant message someone in China, and it's not like, hey, wow, they got it like in a second, right? Because those long connections are made via fiber optic cables. So what happens? If you access the internet, what happens is you're on our network, okay? You go to something called our web server, which has a connection to our internet service provider, which I think used to be Comcast, but I think they just changed. So I don't know if this will work. Sometimes it does, sometimes it doesn't. But let's go to the command prompt again, and I'm going to type trace route portagepa.com. So what's happening is we need to get to portagepa.com, which is somewhere, right? We don't know where the hell it is. It's somewhere on the cloud. And this is tracing the steps that packet takes to get to that server in I think it's in Pittsburgh. But you see it went from gateway.francis.edu, that's our local server. I don't know what this says, but sometimes you can tell the names. We're now in Pittsburgh, you can tell we're in Pittsburgh here. And this is milliseconds. I know it's taken a long time to trace this route, but this is milliseconds. Sometimes it times out. But sometimes you'll see it go to Chicago, you'll see it go to DC, you'll see it go to Atlanta, you'll see it go to another country. Request timed out. Let's try, let's see. Let's do trace routes. ESPN.com. Let's see if we take a different path. So we're always going to start at our gateway because that's our connection to the internet, the St. Francis University Gateway. Okay, so now we're at, we use ACUP now. Okay, now you see, I'm guessing this is somewhere in Chicago, right? You see the Chico, that's Chicago. I don't know if the 10 means maybe Tennessee. I don't know where the ESPN servers are, but I know they're not in Loretto. So switch map, this looks like maybe LAS. I'm thinking maybe Los Angeles, I'm not sure. But it's probably somewhere in the west, I'm guessing. So this is tracking what's happening to the information when we go to ESPN.com. So if you think about it, it goes through like multiple what we call hops. For when we do something on the internet, it goes through our server to our gateway service provider, which is this ACUP. Everything's going to go through ACUP. Then it picks the best route. It goes through Chicago, looks like it's Tennessee, maybe Los Angeles. It's timing out because it's taking so long. But we get from here to there lightning fast. Think about that. It's traversing all those steps in the process like that because of the power of networking technology. Okay, well, we'll talk about that. You guys were supposed to tell me when it was 9:30. It's 9:34. You fail.
Sorry.
9:33.
Whatever. It's after 9:30.
You said
still
30.
fail.
You said 30.
All right.
Ish.
I give you one job to do. One job. All right. We will pick up on here on Friday, I guess. But if you have issues, you have problems with the assignment, please stick around and ask me those questions. I will be more than happy to help you.